Hello everyone, you are welcome to the GMAT 41's YouTube channel. In this video lesson, I'll be teaching you Boyle's Law, one of the laws of ideal gases. Boyle's Law is a law that was stated by Robert Boyle in 1662 in an attempt to find a relationship between the pressure and the volume of an ideal gas. In carrying out this experiment, Robert Boyle kept temperature and the mass of the gas constant. I would like us to state Boyle's Law. Boyle's Law states that pressure of a gas is inversely proportional to its volume if temperature and the mass of the gas are kept constant. What does this law mean? This law suggests that an increase in pressure will reduce the volume of a gas, or a decrease in pressure will increase the volume of a gas. But this is possible if the temperature and the mass of the gas are kept constant. That is to say, they do not change. Now you can take a look at the screen and you observe a diagram which shows a simple experimental setup of Boyle's Law. Now you notice that the temperature is kept constant at 300 Kelvin. And then what happens when a pressure of 1, say, atmosphere or 1 millimeter of mercury was applied? Then you notice that the volume of the gas in the gas cylinder there was 4, could be 4 cubic centimeter depending on the unit of the volume used. Okay, and then in the second case, the pressure has been increased to 1.33, say, millimeter of mercury or atmosphere depending on the unit of pressure. And then you observe that in increasing the pressure on the piston, okay, you can see an extra weight added, making it 4 weights. And then you notice that the volume of the gas reduced to 3 cubic centimeter. So this is just the meaning of Boyle's Law. But don't forget, as explained, for pressure to be inversely proportional or related to volume, the temperature and the mass of the gas are expected to be constant. Let us now look at the mathematical expression of this law. First, that pressure is inversely proportional to volume can be written as P proportional to 1 over V. You know, 1 over a quantity is the inverse of that quantity. So P proportional to 1 over V simply means P is inversely proportional to V, where P is pressure of the gas and V is the volume of the gas. Mathematically, we can remove the proportionality sign. Okay, and to do that, we need to introduce equal to and a constant known as the constant of proportionality. In this case, I decide to use K. So removing that sign of proportionality, we will have P equal to K, then times 1 over V. Multiplying out K and 1, the numerator, we get P to be equal to K over V. So equation 1 is one mathematical equation format of presenting Boyle's Law. If we cross-multiply the quantities there in equation 1, we would get pressure times volume, that is PV, equal to K, a constant of proportionality. Equation 2 is another mathematical format equation of presenting Boyle's Law. Now, I am going to tell you something. In mathematics, for a quantity to be equal to a constant, it gives us the room, the opportunity, the right to express that quantity in different states. Now, in our discussion of Boyle's Law, we are going to restrict ourselves to 2 states. The initial state of the gas and the final state of the gas. The initial state of the gas, we are going to be using subscript 1, and the final state of the gas, we are going to be using subscript 2. Therefore, from equation 2, if pressure times volume is equal to constant, we can now write P1 times V1, which is equal to P2 times V2. What do we mean by that, which gave us equation 3 asterisk there? It's simply telling us that if pressure times volume PV is equal to constant, then we can write the initial condition of pressure times volume of the gas, which is P1 V1. And this will be equal to the final condition or state of the gas in terms of pressure times volume, which is P2 times V2. Now take note, if the gas exists in say 3 or 4 or even more forms or states, we can just simply write the equation as P1 V1 equal to P2 V2 equal to P3 V3 equal to P4 V4 equal to down to the number of states or conditions that the gas exists, Pn Vn. Don't worry about that. As we continue in our study under thermodynamics, we are going to learn this format of analyzing gases when the gas molecule exists in several states. So please friends, take note of equation 3 asterisk for calculation purposes, P1 V1 equal to P2 V2. We shall use this equation to solve mathematical problems related to gas law in the case of Boyle's law. Also take note of equation 2 and equation 1. Equation 1, 2, 3 are mathematical equations that expresses what? Gas law for Boyle's law. And then remember that we have P to be proportional to 1 over V. Also another form of expressing Boyle's law. At this point, I would like us to take a look at two graphical representation of Boyle's law statement. In one of the graphs, we are going to see pressure plotted against 1 over V. And in the second graph, we would see pressure plotted directly against V, volume. Our interest is to see the shape of the graph in these two cases. In the first case, plotting pressure against the inverse of volume, that is 1 over volume, we are going to get a graph which is a supply curve graph. You can see from the origin, the graph extends forward, okay? Telling us that as pressure is increasing, 1 over V, 1 over volume is also increasing. That shows something like direct proportion. But remember, Boyle's law states that pressure is inversely proportional to volume. Now, the reason why the first graph showed us a direct proportion relationship is because we plotted pressure against what? 1 over V already. So you want to take note of that. In that case, the graph will be like a positive graph, okay, that as pressure is increasing, 1 over V is also increasing. Then in the second graph, you notice that pressure is plotted against volume directly. Now in this plot, we did not consider the inverse relationship between pressure and volume anymore. We go directly that pressure is plotted against volume. Now in the experiment under Boyle's law, the value of pressure, if it is increasing, the value of volume will be decreasing. Okay, so since we didn't take the inverse anymore, in plotting pressure against volume directly, you see the shape of the graph. It is a demand curve, all right, a negative graph, showing us that as one quantity is increasing, the other quantity will be decreasing. For example, as pressure is increasing, volume will be decreasing, and if pressure is decreasing, volume will be increasing. All right, we shall now take a question to apply Boyle's law formula. Example: 375 cubic centimeter of a gas has a pressure of 1000 millimeter of mercury. What will be the volume if the pressure is reduced by 75%? Solution. The first thing we have to do is to identify the data, the information, the values given to us in the question, and then get to find out what we are actually looking for. In the question, the initial volume was given as 375 cubic centimeter, and this corresponds to a pressure of 1000 millimeter of mercury. So V1 is equal to 375 cubic centimeter, P1 is equal to 1000 millimeter of mercury. Now the question proceeds to ask, what will be the volume? So we don't know the final volume, V2. That will be equal to question mark. That's what we are looking for. If the pressure is reduced by 75%, now the final pressure. But take note, we are told that the pressure is reduced by 75%, which means whatever the initial pressure is, for example, in this case, 1000 millimeter of mercury is our initial pressure, P1. The final pressure will be the initial pressure reduced by 75%. Now recall, total percentage is 100%. So if something has been reduced by 75%, then we only have 25% left. Therefore, P2, which is the final pressure for this problem, is going to be 25% of whatever the original pressure is. 25% is 25 over 100, which gives us 0.25. So P2, the final pressure, is 0.25 times the original pressure P1, which is 1000 millimeter of mercury. Working this out, we get that P2 is equal to 250 millimeter of mercury. Now, having considered the information given to us in the question, you agree with me that it fits Boyle's law. Therefore, we are going to recall our equation 3 asterisk. That's P1 times V1 is equal to P2 times V2. This is the formula we are going to use where we are calculating for the value of V2. All we need to do is to substitute the values of the quantities we know in the problem and then solve for the unknown V2. P1 is 1000, V1 is 375, so we have 1000 times 375 equal to P2 is 250 times V2 we don't know, so we have 250 times V2. Multiply 1000 times 375 and that gives us 375,000 equal to the right hand side 250 times V2 will give us 250 V2. At this point, we are going to divide both sides by the coefficient of V2 which we are looking for. The coefficient is 250. Now if we divide the right hand side by 250, we'll be left with V2. Therefore, V2 will be equal to 375,000 divided by 250. If you work this out, your calculator or however I want to simplify, we are going to get the final volume of this gas under this condition, V2 to be equal to 1,500 cubic centimeter. And this is actually how we calculate for the final volume of a gas, as we have in this problem. I hope you enjoyed this video lesson. Please like and subscribe to my YouTube channel at GMAT41. I appeal to you friends to please share these video lessons to other scholars, invite them to GMAT41's YouTube channel and encourage them to also subscribe. We have wonderful academic tips from here at GMAT41. In fact, there is no end to whatever you're going to learn from this channel. I hope to see you in our next class where I will be teaching you about another gas law, the Charles Law. However, you can join our full range of learning classes on Telegram with just an affordable monthly subscription fee. You can contact GMAT41 on the number showing on the screen, and you would get further information on how to access our complete video lesson on this. Thank you, and see you in our next class.